Welcome to Maths for All. I'm Aisling Flynn. This is Higher Level. In this video we have a question on statistics. It's from the 2020 examination for paper 2, question 8. It's quite a long question, there's lots of parts, worth 70 marks, so you can take it in small pieces if you wish. Okay, an airline company, Sky Airways, has designed an aptitude test for people applying for jobs as trainee pilots. The aptitude test is scored out of 500 marks. The results are normally distributed with a mean score of 280 and a standard deviation of 90. The top 25% of people taking the aptitude test are invited back for interview. Find the minimum mark needed on the test in order to be invited back for interview. Okay, so how do we use the information given? Well, firstly, it's important to note we're talking about a normal distribution. And we are given a population of all the people that ever took the test. Mu is 280 and their standard deviation is 90. Now we're looking for the top 25% of people. So we need to visualize our normal distribution. Okay, it will have the mean in the center there, and what we're looking for is we're looking for the mark here. Okay, so if mu is 280, what mark is here above which there are 25% of the people taking the test? Okay, so it talks about a minimum mark. Okay, so that's where X is here, and there are 25% of people above this. And therefore, which might be more useful, there are 75% of people below this. Okay, so we're going to use z-scores to answer this question. The definition of the z-score for a full population, which is what we have information for, is your value minus the population mean mu over the standard deviation. Okay. We're going to use our Z tables to find the value of X. Now the Z tables always give the probability to the left of your value. So we're looking for the Z value. So what Z value, okay, gives the probability that our X lies, my notation may not be perfect here, less than or equal to 75%. Okay, so we're looking for a z-score, a z-value that gives 75%. Okay, so what we're going to do there, how we're going to find that out, okay, is to use the Z tables. So I want you to keep in mind this value of 75% or 0.75. So let's look at our Z tables. Okay, so here are our Z tables. Now what are we looking for? We're looking for the Z score that gives 75% of data below it, or 0.75. Okay, so the Z scores are along the side and the top, and the probabilities or the percentages are here in the table. So we're looking for a value that's as close as we can get to 75%. Okay, so going down the page, you'll see these two values here are the closest we can get to 75%. Okay, and because we don't want to include anybody who is lower than the top 25%, we have to overestimate here. So this is the z-score we're going to choose, right? Or that's the probability we're going to choose, is just over 75%. And what z-score does that correspond to? If we go to the side here, we get the first digits of the z-score. Z equals 0.6, and if we go up we'll get the next digit in the next decimal place, so 0.68. That's our Z score. Okay, so take note of that and we'll bring it forward to the next slide. So we've learned that Z equals 0.68. Okay, but that's not what we were asked. We're asked to find the minimum mark. Now, so we have our definition of Z score here. Now we know what Z is. We're looking for our mark, which we'll call X. We know the population mean and we know the standard deviation, so we can fill in everything else. Okay, so 0.68 equals X, which we wish to find out, minus mu, which is 280, divided by the standard deviation, which is 90. Okay, so now let's solve for X. So we get 0.68 by 90 is equal to X minus 280. When you multiply that, you get 61.2, and then we'll add 280 to both sides, and we get a mark of 341.3. Okay, which gives us, if they're given whole number marks, the minimum mark will be 342. Okay, so let's check the marking scheme on that. So using our Z score formula, yes, there are 15 marks going for this. We got 0.68 and we got 342. So you have opportunity to gain partial credit. Okay, if you get 4 out of 10 if you write down what mu or sigma are. If you got the Z score 0.68, you can get 7 out of 15, and if you basically did most things right, equation in X fully substituted, so if you got this far and stopped, you get 11 out of 15. So part 2 of that question, anyone who scores above the 40th percentile can resit the test later. Eileen scored 260 marks in the test. To find out whether or not Eileen is eligible to resit the test. So let's think of our normal distribution again. Okay, and remember we had a mean of 280 marks. Now Eileen scored less than that. What we have to find out is Eileen, is her score more than the 40th percentile mark? Okay, and therefore is she in the top 60%? So this would be 40% below and 60% above, and her score is 260. Is it in the 60% or is it in the 40%? Okay, so we're going to use our Z scores again. Okay, and what we know about Z scores is that if her mark is below the mean, it gives a negative Z score, and the Z score tables don't have values for negative Z score, so we have to equate it to something we can get from the table. Okay, and what we can do there is we can take the value for 60%. So what is the probability that the piece of data lies in the bottom 60%? So the Z scores will give probabilities to the left of a marker. Okay, so it is the reverse or the mirror image of what we're looking for. So we can use 60 as our percentage. Okay, so we're looking for the corresponding Z score for 60%, and we'll go to our table to do that. Okay, what are we going to do? We're going to look for 60% or 0.6. So looking at our table here, I find these two values, and the closest value to 60% would be the 0.5987. Okay, these are approximations, of course, and that results from a Z score of 0.2 is the first part of the number, and the next digit was 5, so 0.25 is our Z score. So we found the Z score to be 0.25, and if we're to equate it to this picture, what's the chances she is above that level. Okay, so this should have a z-score of 0.25 but minus 0.25, okay, because it's below the mean. So now let's calculate Eileen's z-score. So we'll have 260 minus the mean, which is 280, over our standard deviation, which was 90. Okay, and when you calculate that, you get minus 0.22. So that means that her score is closer to the mean than the 40th percentile, and minus 0.22 is greater than minus 0.25. So yes is the answer. You should give a conclusion for full marks. She is eligible to resit. So here's the marking scheme for that. And yes, she is eligible to resit the test. Okay. Here's our z-score of minus 25 and minus 0.22. Okay. Now alternatively, you can do it via the z-score route in the beginning. Okay, 10 marks for that. Alright, again, it's opportunity to gain different partial credits along the way. Okay, B part 1. Explain the relevance of the z-scores minus 1.96 and 1.96 in the standard normal distribution. Okay, so they're way up here, 1.96 and minus 1.96, and we've learned that 95% of the population lie between the z-scores of those minus 1.96 and plus 1.96. Okay, they correspond to plus or minus 2 standard deviations above or below the mean, which is in the center, and anything outside of that is very much considered an outlier. So short explanation, draw a picture if you like, and actually yeah, you could draw a picture if you like and write 95% in there, shade it in. You'd probably get your marks for that. Okay, so there were 5 marks going for that. 95% of the data lies in the interval minus 1.96 to plus 1.96. Okay, if you just wrote 95%, you get 2 out of 5. So part 2, Trans-Sky Airways surveyed 2,500 of its passengers about a new service it proposed to introduce. The variable p-hat is the proportion of respondents in the survey who said they would use the new service. The radius of 95% confidence interval of the survey was 0.01568. Find the value of p-hat where it lies between 0.5 and 1. Okay, so some language there I haven't come across before. The radius. Okay, and actually what this refers to is the margin of error. It means that the true value is likely within that radius or within that tolerance. Okay, so how are we going to solve this one? Okay, so margin of error, we are dealing with proportions. Okay, p-hat, and so we need the correct margin of error. Alright, whenever I can't recall the definition for the margin of error, I refer to my formula and tables books. Okay, so let's have a look at that. So we are talking about proportions, and a sample of 2,500 was given to arrive at this proportion. Okay, so we look to the sampling section of this page, and the standard error of the proportion is given here. although that's not what we use. Okay, but it tells me which version of the error that I've learned I should use. Okay, so it's the one that involves P. Okay, and if I go to the next slide, we'll write down what we've learned to use as the as the margin of error. Okay, so we've learned to use this definition for sampling. So it's 1.96 by, and this is where the formula book came in handy. All right, it's the one with P. P by 1 minus P over N. Okay, now we also learned that when you don't have P for the whole population, you can use P hat from your sample. So that's what we'll use. Okay, P hat, oh no, that's what we're trying to find out. Sorry, okay, and N was 2,500. And we do know that we do know the margin of error in this case is 0.01568. So we should be able to solve for our P hat. Okay, so substituting in our information, 1.96, and we replace that with P hat over 2,500. Okay, so we've got an equation here now with just one unknown variable, so we should be able to solve it. Okay, so let's just work through that. The first thing I'm going to do is divide both sides by 1.96, and we'll be left with this. Okay, so we get 0.008 equals to this square root. Okay, now to deal with the square root and to get access to P hat, we are going to square both sides. And if you square 0.008, you get 0.000064. Count your zeros. Don't drop one by accident. Over 2500. Multiplying now by 2,500 on both sides, and we will get 0.16 on the left, and we have our P by 1 minus P here. Okay, let's multiply out that bracket. 0.16, we get P hat minus P hat squared. So can you see how we're going to solve this? It's going to be a quadratic equation. Let's bring everything to the left. So we get plus P hat squared minus P plus 0.16 equals to 0. Okay, so it's a quadratic equation. I don't think we'll be factorizing because we have decimals. We'll use our quadratic equation, which of course is x equals minus b plus or minus square root of b squared minus 4ac over 2a. You'll find that in your algebra pages of the formula and tables book. Let's substitute our values. 1 plus or minus, so 1 is our b, so the coefficient is minus 1. Of course, if you want to make a list, a is 1, b is minus 1, and c is 0.16. Okay, so minus 1 gives us 1 for a start. Then we have minus 1 squared minus 4 times 1 times 0.16, all to be divided by 2 times 1, which is 2. Now use your scientific calculators to do that quickly, and you'll get for the plus option we get P hat equals 0.8. For the minus option you get P hat equals 0.2, but the question said it should lie between 0.5 and 1, so we will not count the 0.2 one. We'll say P hat is 0.8, and what does that mean? It means that they're 95% sure that 80% of people would use the new service, of passengers would use the new service. Okay, so let's check our marking scheme. So yeah, there's our margin of error, and here is the value given in the question. worked through it there. They've left theirs as a fraction. So 4 over 5, which is 0.8 or 0.2, and that they discount this 0.2, same as we did. There's 10 marks going for that. Partial credits available along the way, 3 marks for writing down your margin of error without the 1.96. Okay. If you get out your quadratic formula fully, you get 5 out of 10. Or formula fully substituted if you put the numbers in the right place. So if you get to this stage, you get 5 out of 10, and if you form the quadratic, you'll get 8 out of 10. Okay, part C of the question. The weight of the airline passengers' carry-on luggage is normally distributed with a mean of 12 kilograms. The airline has recently introduced a fee for non-carry-on luggage. After the fee was introduced, the airline expected the mean weight of carry-on luggage to change. They selected a random sample of 80 passengers and weighed their carry-on luggage. The sample mean was 13.1 kilograms and the sample standard deviation was 4.5 kilograms. Test the hypothesis at 5% level of significance that the mean weight of the carry-on luggage has changed. State the null hypothesis and the alternative hypothesis and give your conclusion in the context of the question. So lots to read there. We'll take it piece by piece. Okay, so it's a hypothesis testing question. First thing to do is to decide what's the hypothesis to be tested, the null hypothesis, and we've told exactly what to test, that the mean weight of the carry-on luggage has changed. So that's H0 straight from the question. The mean weight of carry-on luggage has changed. Okay, H1 then, the alternative hypothesis, is the negative of that. The mean weight of carry-on luggage has not changed. Okay, so we have to go through the process now for this one. Okay, so let's read through and let's see what we have in the question, what pieces of information. So we have the normal distribution, we have a mean of 12 kg, so I'm just going to make a list here. Mu is 12 kg, so that's of the population. We have a sample of 80 passengers, n equals 80. We have a sample mean. Okay, x bar is 13.1 kg. Okay, and we have a standard deviation equals 4.5. Okay, so again we need to set up our confidence interval and see does our new value fall within that. So we don't have proportions in this question, so we can't use the margin of error that we used in the previous question. Let's refer back to the formula book. Okay, so we're still sampling and we're given means, so we're going to use this as part of our margin of error. Okay, but of course we'll have the factor of 1.96 as well. Okay, so we'll bring that forward to the question. Okay, so the standard of error, or the margin of error we're going to use is 1.96 by our sample standard deviation over root n. Okay, let's fill in the numbers for that. 1.96 by 4.5 over root 80. Okay, and when you work that out you get 0.9861. Okay, we're going to set up our interval now. We're trying to see, does our 12 kilograms, our sample mean, does it fall within this, our population mean, the real one, 12 kilograms, that's what we started with, has it changed? So from the sample we got a sample mean of 13.1. We'll check it against the error. Okay, we'll create an interval with the sample mean minus the error against this, or up to the sample mean plus the error, and does our 12 kilograms fit in there? Does it agree with the sample results, or has it, if it doesn't agree with it, well then something has changed. Okay, so let's put in the numbers there. We get 13.1 minus 0.9861. We're checking, is it within the range, and the other side of the range we add the margin of error, and the two values we get are 12.1139 and 14.0861. Now 12 kilograms was the original mean, and you can see that it does not fall within this range or within this interval. Okay, so we'll write it down. 12 kg does not fall within this interval, and then we're asked to give a conclusion. Alright, we've tested the hypothesis, we have to give a conclusion in the context of the question. We're going to look back at our hypothesis. H0 was the mean weight of the carry-on luggage has changed. I think it has. So we fail to reject H0, and we'll write the mean weight of carry-on luggage has changed, or has appeared to change, okay, within our confidence interval of 95%. Okay, let's see the marking scheme there. Okay, they've used Z scores, by the way. You can review that if you like. We didn't do it that way in class. There's 10 marks going for that. There's our hypothesis. Okay, and there's our conclusion. Now, part D of that question. The company bus can carry passengers up to a total maximum weight allowance of 30,000 kilograms. The weight of passengers is normally distributed with a mean of 73 kg and a standard deviation of 12 kg. 40 passengers board the bus. Find the probability that the total passenger weight will be over the maximum weight allowance. Give your answer as a percentage to 2 decimal places. Okay, so the way I approach this is, if the total is over 30,000 kg, the weight allowance is exceeded, then the average person of the 40 that got on the bus is more than 73 kg. Okay, so let's see what the average person weighs. So to do that, we'll take 30,000, we're going to divide it by 40 to find the average person. Okay, now if we do that, we get 75 kgs. So on average the passengers can't be more than 75 kgs. Okay, so we can use our normal distribution, because that was mentioned. Okay, normally distributed. We have our mean here, and we have a standard deviation, and we can use Z scores to see is the average person, or what portion of the distribution will be over 75 kgs. So let's find the Z score of a 75 kg passenger. So remember, Z scores are gotten by this. Okay, and we have all the information we need for that. Okay, let's take 75 as our passenger, 73 as the mean from the question, and 12 as our standard deviation. And we get a z-score of 1.05. Okay, the tables only go to 2 decimal places, so I can leave it there. Alright, so let's have a look at our normal distribution. It's always useful to sketch and figure out what's going on. So 73 was the mean of the passengers. We don't want to exceed 75, so we're asked to find the probability that we do. So we're looking for this section of the graph, okay, which is greater than. And we know that the Z tables give probabilities for this area here, less than, so are to the left of. Okay, so we'll have to use, what's the probability? Or we'll have to use 1 minus the z-score of 75. Okay, so 1 minus the probability that z is less than or equal to 1.05. Okay, so we need to refer to our z tables. Okay, so we're working with a z-score of 1.05. We have 1.0 at the bottom, and we go across so we find 0.05. Okay, and we get this percentage here. Okay, take note of that, 0.8531. Okay, so our probability that we'll exceed the weight will be, from here, it'll be 1 minus 0.8531, which is 0.1469. That's as a decimal, or 14.69% to the 2 decimal places that were requested. So here's the marking scheme for that bit, another 10 marks. Alright, and yeah, that's exactly what we got. This is the probability that the bus with 40 passengers will be above the maximum weight allowance. Okay, again, partial credits gained along the way. If you just divided the 30,000 by 40, you'd get 3 out of 10. If you'd got the z-score out, you get 5 out of 10. And if that's substituted, and if you calculated it fully, you get 8 out of 10. So always start somewhere and give it a go. Okay, last part of that question is part E. And this is a very interesting one. Okay, really like this. A list consists of 8 whole numbers. They are labelled A to H as shown below. The numbers are all greater than 0 and are ordered from smallest to largest. The difference between any 2 adjacent numbers is 2 or more. The median of the list is 12.5. The lower quartile, the median of 4 lowest numbers of the list, is 7.5. The interquartile range is 12. The second largest number is 23 as shown. The range of the list is 21 and the mean of the list is 13.5. Now, so much information there, you'll have to read it many, many times as you go along. I'm going to start here. The median of the list is 12.5, so you really need to know your averages and what they mean. So median is the middle value, and because this is 8, it'll fall between the 4th and the 5th value. So I'm going to mark in 12.5 there. Okay. The lower quartile, we're told, is the median of the lowest of the 4 lowest numbers is 7.5. So again, half that. So 2 and 2, we get 7.5 here. It's halfway between B and C. The interquartile range is 12. Now, the interquartile range is the difference between Q1 and Q3, the third quartile. So if the difference between those is 12, well then 7.5 plus 12 will bring me up to Q3, which is 19.5. If you subtract them, you get 12. Right, these will come in useful in a little while. Second largest number is 23, that's grand. The range of the list is 21, we'll come up to that in a minute, and the mean of the list is 13.5. So where to even start? Okay, and it's trial and error and figure it out. Okay, I'm going to work here with the 23. Halfway between F and G is 19.5. Okay, so the difference between 23 and 19.5 is a gap of 3.5. So by the definition of median, the gap to F should also be 3.5, so subtract 3.5 from 19.5 and I get 16. Okay, and we'll be doing something similar along the way with the other ones. So now I'm stuck again. I'm going to write down what I do know. Okay, let's look at the 7.5 for the Q1. I can write that B plus C over 2 is 7.5. Similarly, D plus E over 2 is 12.5. And I can multiply by 2 with those. I get B plus C equals 15. Okay. I can do that here as well. I get D plus E equals 25. Alright. What else can I find out? We're told about the range. Okay. The range of the list is 21. Well, the range is the maximum H minus the minimum A is 21. So that may come in useful. Alright. And then the last piece of information is the mean. Now the mean is when you add them all up. So let's write that down. A plus B plus C plus D plus E plus F plus G plus H, all divided by 8 equals 13.5. Now look at the information we have above, guys. I can replace B plus C with the number 15, D plus E with the number 25. I know F and I know G, and I'm left with A and H. Now what can I put in there? I can rearrange this equation. I can say that H equals 21 plus A. And then what I can arrive at is an equation where I can solve for A. Okay, so writing that in, I get A plus 15 plus 25 plus 16 plus 23. Now instead of H, I'm writing 21 plus A and multiplying both sides by 8. So 13.5 by 8 is 108. Okay, so I'm getting places now. Simplifying, I get 2A plus 100 equals 108. Therefore 2A equals 8 and A is 4. So we're getting places here now. 4. Okay, from that I can fill in H because the range was 21, so the difference between them is 21. So put in there 25. So for H, if 25 minus 4 is 21. And then the only other piece of information that I haven't used yet is the two adjacent numbers. The difference between them is 2 or more. Okay, so I do know that B plus C is 15. Alright, now that could be 1 plus 14, 2 plus 13 and so on, but that's not going to happen. The minimum value of B has to be 2 bigger than A, which is 6, and 6 plus 9 gives 15, or it could be 7 plus 10. Sorry, no, it would be 7 plus 8. Now 7 plus 8 doesn't work because they're too close together. There's not 2 between them. So I think it's 6 and 9. And likewise, the minimum value of D must be 2 bigger than C, which is 11. And D plus E gives 25, so it'd be 11 plus 14. Okay, that works. If I go 12 plus 13, they're too close together. Okay, and then they get too close to 16 on the other side. So it's 11 plus 14. So a lot to take in there. Maybe pause and try it for yourself. Let's check am I right first though. And yes, we're right. And there was 10 marks going for that.